I'm I'm kind of guessing why you picked number 41 in lesson 9.2 in the exercise set. And again, we're invited to use the elimination method. And I think the reason why is because of the fraction. But you can eliminate the fraction if you like. You can eliminate the fraction. So for example, if I multiply by 8, and look what happens. We're not doing anything on the first equation. So 16x plus 5y equals 6. So this is 1. 8 times 7 equals 56x. And then 8 and 8 cancel, so you end up with 5y equals 8 times 2 equals 16. So this is still number 2. Does it make sense? So we have, pretty much the same system, but, looking a little bit different. So notice that we can get rid of the y's, because if I had a negative here, that means I can multiply either the first or the second equation by negative 1. I mean, I chose the second, not a big deal. So you can say negative 1 times equation let me get rid of, okay, equation 1 plus negative 1 times equation 2. So that's what's happening. So let's write the first equation as is. So 16x plus 5y equals 6. So this is 1. So notice that because we did that multiplication by getting rid of the fraction 5 over 8, the system turned out to be very, very easy, a lot easier than what we may have thought initially. And then because you're multiplying everything across by negative 1, so they are all positive, so they will become negative. So negative 56x minus 5y equals negative 16. So this is 2. Okay? So draw the line, we're adding. So take away 16 from 56, you're going to end up with negative 40x. This is gone because we added and we eliminated. And you got negative 10. So dividing both sides by negative 40, okay, so you get x equals positive 1 over 4. Okay, because two negatives make it positive. Cancel the zeros if you like, and you're left with 1 over 4. So now because you have one of the two variables, you can go up to the original system of two linear equations and pick either the first or the second and plug in for x so that you can solve for y. So I'm going to pick on the second if you like, just so that we make it a little bit challenging. Use equation 2 to solve for y. Okay, so I have 7, so instead of x I'm going to plug in 1 over 4 plus 5 over 8 y equals 2. So obviously 7 times 1 equals 7 over 4, and then plus 5 over 8 y. And then I can do this if I want to. 2 over 2, so I can have an 8 equals 2 over 1 times 8 over 8. Okay? So 2 times 7 equals 14. 2 times 4 equals 8. Plus 5y, let's move the y up. 8, and then equals 2 times 8 equals 16. 1 times 8 equals 8. And again, we did this so we can cancel the fractions. And because they share the exact same denominator, we can do that. So you end up with 14 plus 5y equals 16. So now this looks much better, right? So if you subtract 14 on both sides, you get 5y equals 16 minus 14 equals 2. So y equals 2 over 5. So you say solution is a point, so it's going to be 1 over 4 and 2 over 5. So this is going to be your solution, my friend. Okay? And again, this was done using the elimination method. as required in the exercise set 9.2. So now I'm going to use the exact same thing, but this time I'm going to use substitution. And it's a little bit ironic because, you know, when we solve for the second variable y, we are substituting, see, for x right here, we're substituting what we solved, so it's kind of strange. But substitution, you know, as a separate method means that we are solving for one of the two variables on one of the two equations and then substituting on whatever we solve for that variable on the other linear equation. So I'm going to do just that in case the solution appears a little bit suspicious. Now, the way to tell whether this is correct, of course, you would plug them into the original equation, and is the left side equal to the right side or not. So, but we're going to do this type of confirmation simply by using another method, and if the answer is a match, and then that should be enough, I think. Okay, so let me rewrite this again. 16x plus 5y equals 6, so this is 1. And then 7x plus 5 over 8y equals 2, so this is equation number 2. Okay? And the method we're going to use is substitution. So again, you can solve for x on the first and then substitute for x on the second equation, or you can solve for y on the first and substitute for y on the second equation, or solve for y on the second and substitute for y on the first, or solve for x on the second and substitute for x on the first. So you see what I'm saying? I mean, you can come up with 4 types of approaches, so depending which one you pick. But for the most part, you would want to pick the one that is the easiest. But looking at this, I mean, the easiest would be to solve either for x or y on the first equation, and perhaps avoid the second one. So you can say let's say solve for x on equation 1. So let me write it down. 16x plus 5y equals 6. So I need to isolate the term containing the x, so 16x equals negative 5y plus 6. Okay, because this is positive becomes negative, but this is already positive, so you don't need to change that. So divide everything by 16, and this way x equals negative 5 over 16y plus, and I'm going to leave it like this if you wish, 6 over 16. I could have simplified as 3 over 13, but I mean 3 over 8 rather, but I'm going to leave it like this. Okay, so now this is still number 1, equation number 1. So I'm going to substitute for this x because I already have the x. So substitute 1 into 2 for x. Okay, because that's exactly what we did for x. So I'm going to say 7, and then instead of this x, I'm going to dump all this messy thing. Negative 5 over 16 y plus 6 over 16, and then plus 5 over 8 y equals 2. Okay, so notice again, as messy as it may look, the equation turned out to be with one variable. And again, the expectation is that we get, because we're solving for y, the expectation is that we get 2 over 5. That's the expectation, 2 over 5. So let's find out if that's the case. So let's multiply here. So you're going to end up with a negative number. So negative 7 times 5 equals 35. So over 16y. And then 7 times 6 equals 42 over 16. And then I can modify this. Let me do this. 2 over 2. Can you see I'm multiplying by 1, so I can get a 16 at the bottom. So I can say plus 2 times 5 equals 10, and then 2 times 8 equals 16, so this is going to be y, and then equals, and I can do the same here. Picture this as 2 divided by 1, and then multiply by 1 in the form of 16 over 16. So 2 twice 16 is 32. 1 times 16 equals 16. So again, the reason is because you can cancel those. You can cancel those. That's the whole idea. So we end up with negative 35y plus 42 plus 10y, and then equals 32. Okay, so we can work with those two because they're like terms. Negative 35y plus 10 equals negative 25. Negative 25y equals 32. This is 42, goes in the other side as negative 42. As negative 42. So if I continue up here, I have negative 25y equals, and 32 minus 42 equals negative 10. Negative 10. So because you have negatives on both sides, you can say 25y equals 10. You can multiply both sides by negative 1, so you get positive. So when you divide by 25, again, the expectation is to get 2 over 5. Well, y equals 2 over 5, because when you divide by 5, 10 divided by 5 equals 2, and then 25 divided by 5 equals 5. And isn't that a match? Isn't that a match? Okay? It is a match, okay? And now it becomes easy, because once you have one of the two variables, you can go to the original system of equations and then pick one of the two. Or we can use this one. Why should we bother, you know? So let's do this. X equals negative 5 over 16. So instead of y, you plug in 2 over 5, and then plus 6 over 16. Okay, well, guess what? I can cancel these 5's, so I end up with negative 2 over 16 plus 6 over 16, which equals negative 2 plus 6 equals positive 4 divided by 16. Divide by 4 up and down. Guess what? You get 1 over 4. So x equals 1 over 4. Solution is 1 over 4 for x and 2 over 5 for y. Is that the case? Well, guess what? It is the case. See, 1 over 4, 2 over 5. Okay? So it does work. It does.